Welcome back to this series of videos. Now, in this video, we're going to be discussing function substitution differential equations, which is a special kind of differential equation. I will explain as we get along in solving dy over dx minus x squared minus 4xy equals 4y squared. Now, let's try moving everything to the right-hand side. So, dy over dx equals x squared plus 4xy plus 4y squared. This is equal to x plus 2y quantity squared. You can check that. Now let's rearrange everything so that it looks nice. Now we can see here there is clearly a function, right? And the x plus 2y is the input, and then like the f of x is the blank squared. So we can substitute using that function. So we're going to be using x plus 2y as v. So since this is dy over dx, we need to differentiate both sides with respect to x. So the derivative of x is just 1. Derivative of 2y is 2 dy over dx. And derivative of v is dv over dx. All right, let's isolate dy over dx. We get dy over dx here. We subtract 1 on both sides, so that happens. And then we have to divide both sides by 1/2. Or 1/2 dv over dx minus 1/2. All right. So let's put everything in the original question. So x plus 2y becomes v, so v squared. dy over dx becomes this 1/2 dv over dx minus 1/2. So 1/2 dv over dx minus 1/2 equals v squared. And from here we have v, we have an v here, so that's going to be good. So let's just put 1/2 on that side. So 1/2 dv over dx equals v squared plus 1/2. While we're at it, let's hmm, we can multiply by 2, but we can directly divide by v squared plus 1/2. So we get on the right hand side it's 1, on the left hand side it's dv here, dv over dx. And then here it's 1 over, let me just arrange it. 1 over 2 times v squared plus 1/2. Now we can integrate both sides with respect to x like we always do. And the integral of 1 is just x, so that's easy. Plus c, we can't forget plus c. And the integral of this one, well, what is that? Well, the let's put 1/2 here. That's long, but it'll work. And then what is the integral of 1 over v squared plus a squared dv? That's 1 over a, then arctan of v over a. You could check that one out, but that's the formula. So we multiply this by 1 over root 2, arctan of v over square root of 2, and there you go. So now what we have to do is to multiply everything to the other side. This is constant 1. Let's just label it as C1. And then arctan of v over square root of 2 is 2 square root of 2 times x plus c2. Constant times 2 times root 2 is just another constant. And then from here, we know that this is arctan, so we can take the tangent of both sides. We get v over square root of 2 be equal to tangent of 2 square root of 2 x plus c. C2, c is just the same, it's just a constant, so we can label it as c. Isolate v for now, so v equals square root of 2 tangent of this 2 square root of 2x plus c. And we know v is equal to x plus 2y. Let's isolate y so we can get a function. So 2y equals negative x plus root 2 tangent of 2 root 2 x plus c. And one more time, let's divide both sides by 2 to isolate y. So get y equals negative x over 2 plus square root of 2 over 2 tangent of 2 root 2 x plus c. That is our general equation for this differential equation. That's nice. So let's move on to another function substitution question. dy over dx equals e to the 2x plus 3y minus 1. This one is more obvious what the function is. It's 2x plus 3y minus 1, and e to the x is the outside function. So we're going to substitute the exponent right away. 2x plus 3y minus 1 equals, let's say, v again. The derivative 2 plus 3 dy over dx equals dv over dx. Let's isolate dy over dx by subtracting 2 and then multiplying both sides by 1/3. And we're going to fix that later. So let's go. dy over dx, no, we replace dy over dx to 1/3 dv over dx minus 2, parentheses, don't forget, equals e to the v. And now from here, we can isolate a dv over dx here. So we multiply first by 3, then we add 2 in order to get dv over dx by itself. Now, we can divide this on both sides. So, because this is already separable. So, 1 over 3 e to the v plus 2, the v over the x equals 1. All right. So, how can we integrate both sides here? No, let's just, one of these sides is already x plus c, 1. And this one, how do we, this is the x, sorry. How do we integrate that? Well, we multiply both the numerator and the denominator by e to the negative v, and this is what happens. Well, e to the negative v over 3 plus 2e to the negative v, dv over dx. So, now here, we can let 3 plus 2e to the negative v be equal to u, and 2e to the negative v, and then negative since the chain rule, dv equals du. Since dv over dx here is dv over dx. So we're going to be doing this. E to the negative v dv dx over dx. It means that we have to multiply by negative 1/2. So we do that outside. And then we get the u over u, which is negative 1/2 ln of u. All right. We can ignore plus c because we're there plus c here. This is then equal to negative 1/2 ln of 3 plus 2e to the negative v equals, let me see, x plus c1. Now, let's try isolating v so we can get on with it. So we multiply both sides by negative 2. So ln of 3 plus 2e to the negative v equals negative 2x plus c2, another constant. Let's raise e to both sides to remove this pesky little natural logarithm. So we get 3 plus 2 e to the negative v be equal to this. So e to the negative 2x plus e to the c2. So this is going to be multiplied by the loss of logarithms, and e to the c2 is another constant. So we get c3, I guess, e to the negative 2x. And then we need to subtract 3 on both sides in order to get 2e to the negative v equals c. Let's just keep it as c unless there's something that comes up. Let's rearrange. Negative 2x. Okay. So we need to divide by 2. Something did come up. So this is C3. Just remember it's C3. So we need to divide again by 2. Yeah, we need to divide by 2. So we get e to the negative v equals negative 3 over 2 plus C4 e to the negative 2x. All right. And then a few more steps. Negative v equals ln of negative 3 over 2 plus c. Let's just keep it c because I don't think it's going to change anymore. There we go. And v then is negative ln of negative 3 over 2 plus c e to the negative 2x. We're not done because v is the 2x plus 3y minus 1, which is now equal to this. So we need to isolate y so that it's clean. So transpose this and that to both sides. We get 3y equals 1 minus 2x minus ln of negative 3 over 2 plus c e to the negative 2x. Divide both sides by 3 in order to finally isolate y. We get 1/3 minus 2/3 x minus 1/3 ln of negative 3 over 2 plus c e to the negative 2x. And that is your general solution as well. A little recap, here's where we started, right? And then we integrated this one, and then we ended up here. It's very long, but it is the general solution. And that's all for now. I will see you in the next video.